Yandel here. You've now reached number 5 in your packet, which means you're getting near the end. That's a good sign. And you'll be working with a simulation called the ramp. And in order to understand it, we need to reach a point where we understand the two pictures that you see here. First, let's just kind of label things and think as we go. This vector right here is the weight of the box. Because of this angle in here, we have a couple of components. Here is the force of the weight perpendicular to the incline. Here is the force of the weight parallel to the incline. Those are both components. Those are both components of the weight. We have a dotted line down here. That is the frictional force trying to hold back the box as you push up the hill. And then here is the normal force, which we know is equal and opposite to that force of weight perpendicular. So there's just everything labeled. This is stuff that we've learned before, things that we've seen before. The trick to this is the comparison between the two pictures. What's happening as we look at these two? First of all, notice that in order for you to move this object up the incline at a constant speed, this force right here has to be the sum of the parallel force plus the force of friction. Obviously, if you make this one larger, this thing will begin to accelerate. F equals ma. You're adding extra force, you get extra acceleration. Notice that on the second picture, things shift a bit, and that's pretty much what this lab is about, noticing the changes. They're all the same exact labels on the picture down below, but things have changed a bit. Notice how they've changed. Notice right here. Notice how the component here is smaller now. Notice how the component pulling this thing down the hill has become larger. Notice how the force of friction has now become smaller. And therefore, it's going to take more force to get this thing moving up the hill. That is a large part of your understanding of how things shift as that angle theta shifts. And it's very important that in your head you see the differences between those two. Remember, the force of friction is mu times the normal force. And as you see that normal force change, you also see the frictional force shift. You can see the frictional force becoming less. One of the reasons it's difficult to stand on a really steep incline is that, first of all, you have a greater force pushing you down the hill, but secondly, the frictional force holding you on the hill has become less, and it's harder to stand. I think if you get those main ideas I've just described, and I know I've done it very quickly, play this a couple times until that makes sense, I think you'll begin to understand how your lab is investigating the motions right in here when they have you do your calculation. Yandel out.